Hello everyone, I'm Norman Wahlberger, and just a quick update on our Algebraic Calculus 1 course. So I want to bring you up to speed with the exciting things that are happening with a new algebraic approach to calculus. So this is all being developed online at Open Learning. We have a full online course that's in the process of being developed. There's the URL. We've been going since January 2018, so almost a year now. And it's a beta version of the course, and I'm hoping that it'll probably finish its first run sometime in the middle of next year, and then we'll be able to consolidate what we've been doing and revamp it and bring it up to a higher level. Right now the access to the course is through Patreon, so if you become a Patreon supporter of mine, then you can access the course. Or if you are a university educator in mathematics, send me an email and I'll sign you up. Currently we have about 250 participants, and we have quite a few comments, almost 3,000 comments, a lot of discussion, a lot of really interesting contributions by various people, a lot of nice explanations. So it's a very interactive kind of thing. It's really a fabulous thing. Okay, the videos themselves are on YouTube at my sister channel, Wild Egg Mathematics Courses. So you can watch the videos there, but over here there's actually quite a lot extra. So the course is organized into 12 chapters, and here they are here. They're almost all in completion except for these last three. These are still being composed, developed as we speak, but in a few more months they'll all be finished. So you can see that there's a kind of a geometrical aspect. We're talking about splines, we have sums of power, some algebra, some curves, tangents, connection with topology and physics, the discrete calculus figures prominently, and then areas of curves leading to the fundamental theorem, and then applications of integration and circular, hyperbolic, and exponential functions or objects. So that's Algebraic Calculus 1, our first course in the algebraic calculus. Now each chapter contains, of course, a video, which is the central resource, but then there's also notes which summarize the content and sometimes go into more detail. Very important, there's a section on worked problems where we lay out solutions to important problems that illustrate the theory and give examples. Then there's another section on homework questions where we try to come up with instructive and also interesting questions for you to hone your skills and your understanding and give you some challenges as well. And then there's a smaller section at the end called links, notation, definitions, where we summarize some extra things. So on each one of these pages, there's room for participants' comments and questions and solutions and PDFs, you can upload them and so on. So we ending up having a nice discussion, lots of interesting comments and people helping each other. So it's a very, very nice environment to be learning. So very roughly, the course is very novel. It does not follow the standard pattern of calculus courses around the world. These days, calculus courses, there's hundreds of calculus texts, and in some sense, there's a lot of overlap between these things. So there's a lot of sort of an orthodoxy there, and people are following the orthodoxy, and people who are writing calculus texts feel very constrained that they have to tick all these boxes that are sort of preordained. But we put all that aside, and we are rethinking the entire subject, no holds barred. We are going to try to really get at what this subject is really about, and no appeals to authority interest us. Okay, so one of the interesting aspects is that the subject is much more connected with linear algebra. In keeping with that, we introduce areas actually via determinants, not via areas of rectangles like length times width. Okay, so that's a very important distinction. There's a geometrical emphasis on curves rather than functions. So it's very geometrical, perhaps a little bit less analytic. There's a strong algebraic orientation. We think of polynumbers or polynomials as sort of the central objects, and we are always looking to frame things first and foremost in that language. And there's a strong discrete or spline component. We think that this discrete calculus is almost as interesting and as important as the continuous calculus. We want to have a sense of these two things as being somehow parallel and mutually interacting with each other. And very notably, there's none of the usual waffling that characterizes calculus courses around the world. Okay? No infinite processes where we pretend that we can do an infinite number of things. No real numbers where we talk about an arithmetical system that we can't actually demonstrate and explicitly give constructions and computations for. And there's no waffling with infinite sets and axiomatics and the usual kind of, Pollyanna story that modern mathematics is based on. Rather, we're working with concrete, algebraic, explicit computations that everybody can see. Everything's on the page in this course. That's what we're aspiring to. Okay, so very different from your standard calculus course, but also very exciting because we're also learning all kinds of new things. We're discovering all kinds of interesting phenomena. So I do hope that you'll all consider joining the course. Okay, this is a historical occasion, really. The course is running for the very first time, and you can get in there on the ground floor. All kinds of new understanding of modern mathematics is going to be built up from this foundation. So don't miss out. Okay, join the course. There's much to learn. I'm Norman Wahlberger. Thanks for listening.